Yeah, I'm Brien Wankel. I work for a company called Lab Zero. And my family and I, we like to go adventuring quite a bit on some pretty long self-sustained trips out in the middle of nowhere. So this has sort of become a passion project to mess around with our vehicle and see what we can do to it. So before I get started, I feel like I should plug Bootleg real quick. This is a project I work on. It's just simple deploy and server automation. I'm totally interested if anybody uses it or has looked at it. Come see me or my partner Rob over there, and we'd love to talk to you. So before we start, I want to give a disclaimer. This is it can be dangerous. You will actually, if you mess around with this and you dive into messing with your vehicle's CAN bus, you can cause bad things to happen. You can obviously you will void your warranty most likely, but you can render your vehicle completely inoperable if you do something wrong. You can also unintentionally disable something that you're not expecting, which can do things like turn off power steering or disable your brakes and that kind of stuff. So with everything that I'll talk about here, I encourage you to, if you're interested, to explore this, but be careful when you do it. And definitely when you're testing stuff out, don't do it on public roads. Do it somewhere safe, private land. I do most of my testing in my driveway, actually. So yeah, just know that you can seriously wreck your car, you can hurt yourself, you can hurt other people. And one last disclaimer, if you find your car in a position or some state that you're not expecting, I'm not responsible, it's not my fault. So, show of hands, has anybody ever wanted to have their own custom smart car? Anybody? Maybe not like this, but maybe something more like an intelligent car. Something like you may have an Amazon Alexa or a Google Home at your house, and maybe you want some of that functionality in your car. So that's what this talk is going to be about. And the way that I've gone about doing that is by tapping into what's called the CAN bus. And the CAN bus is not actually as cool as a Volkswagen bus made out of cans, but it's very useful. So it stands for Controller Area Network, and it's a message-based multiplex protocol that's in most modern cars. It's in all modern cars. If your car is manufactured in '96 or later, you may likely have a CAN bus in there. It was made mandatory in 2008. I believe that's when the OBD2 port was made mandatory. So it's one of the 5 protocols of the OBD2 standard. And the CAN bus provides, it's a message bus that provides lots and lots of messages about things like speed, the state of the gears, whether or not the brakes are on. Yeah, you can see messages about horns, lights, and basically everything that happens in the interior of your vehicle is most likely sending a message or receiving messages on this bus. So the CAN is a 2-wire protocol, like I said, and this I'm not going to get too into the details, but I do want to point this out that it's differential signaling. So there's 2 wires. One is a high signal, one's a low signal, and in vehicles, those 2 wires, the normal state is 2.5 volts. So if it goes up, so if there's a difference, the high wire will go up to 3.5 volts and the low wire will go down to 1.5 volts, and that signal's a 0, if I'm remembering correctly, and the flat state is a 1. This is important to know, not that you have to manage this wire connection at all, but if you're poking around looking for the wires in the wiring harness, it's going to be the ones that are at 2.5 volts. They'll have a steady state at 2.5 volts, and usually it's going to be the only wires in your car that will do that. Well, I shouldn't say usually, but It makes it a lot easier to pick out which wires are which. So there's a hardware side and there's a software side of this project. I'll start with the hardware side, and then at the end we'll dig into what's needed on the software side. So this is the basic needs. You need, obviously, a vehicle with a CAN bus, some sort of computing device to hook up to it. I used a Raspberry Pi 3, and I have a CAN bus interface that connects to that Raspberry Pi 3. And that interface handles the actual low-level communication on that two-wire network. So by the time it gets to me, like all the low-level network stuff's done, and I'm just getting messages back. And then you have to come up with the wiring to actually hook all this stuff into the vehicle. So this is Jolene. This is my family's little adventure vehicle, and this is our victim that we ripped apart to play around with it. And this is the PyCAN 2. The website is skpang.co.uk. It's really small, but it's written on the PCB there. So if you're interested in this, this is probably the easiest device to use. This is the one with that will also take a 12-volt power hookup. There's cheaper ones. I think this was about 40 or 50 bucks, maybe a little more. They make one that's 10 or 20 bucks cheaper that doesn't have the power. So if you want to power your Raspberry Pi with a USB connection, you can do that. Save yourself a little money. My ultimate goal was to actually have this thing stashed away, and I didn't want USB cables running around to power it. So I tap into the 12-volt power to power this thing. They also make ones that have multiple CAN connections. So this just has one. It's actually those purple wires that are coming in from the top right. They make another one that's dual interface. I think they make one that has 3 or 4 interfaces, so you can do a little bit more fancy stuff. So, like I said, this is part of the OBD2 standard. So if you have a car that's 2008 and newer, you'll have an OBD2 port near your steering wheel. So it has to be within 2 feet, I believe, of the steering wheel. Usually it's like down to the left or down to the right. And you've probably run across this thing if you've ever poked around trying to figure out how to unlatch your emergency brake. Sometimes these are covered with a panel, and your service manual should point out exactly where this is. So this is a kind of dark picture. If you look close, it's right there. It's a D connector. I think it's DB9, I think is the... don't quote me on that. I actually don't remember. So in my case, like I said, I wanted to have all this stuff hidden. So I went the extra mile, and I completely ripped apart my dash, which was not as easy to get into as I was expecting. So I actually had to remove I had to remove 3 or 4 different parts of the dash, then trace some wires, and this picture cuts off, but I actually had to remove the center console and my stick shift knobs and all that stuff. But I did manage to get to, you can kind of see right here, if you look real close, it's you can see it's total chaos. So I don't recommend going this route unless you're absolutely committed. That was a day that I will never get back. So what I did is and now I need to wire it up. So I have the computer, I have the interface. I bought some aftermarket wiring harnesses, and I wired together a T-Connect harness that I could use to splice off my power wires and my high and low CAN bus wires. And this actually just plugs into, I unplugged from the head unit of the stereo, and then I can plug the main wiring harness into this T-Connect, and then the other connector of the T-Connect I plug into the head unit. So it was the easiest way that actually, if I wanted to, I could take this out and it would appear stock again. I didn't want to. I wasn't totally committed enough to start cutting directly into the wiring harness. So, cost, this was maybe like $10 in wiring harness parts and 10 minutes of soldering. So here's the connectors I was mentioning. So this is the harness actually in there, hanging out on the right there. And then I have it stuffed in the dash and run through, and it pops out into the glove compartment where I have my Raspberry Pi. This is the first time I hooked it up. It's now actually in an enclosure, much more protected. But this was the first day I hooked it up just to make sure that it was going to work and that it wasn't going to make a bunch of smoke come out of my Jeep. So that's it. Once you get to that part, you're done with the possibly more uncomfortable hardware side, because that's when, like, you know, if you're going to screw something up royally, it's probably going to be during all the wiring. So the software side, the Raspberry Pi CAN interface is an SPI interface. So you have to load some extra drivers to get that working. I created in order to do it, you have to build a new nerve system. There's no way to do it with just overlays. You have to actually create and recompile a nerve system, which is pretty tedious. And if you happen to use Raspberry Pi and a PiCAN 2, you can Google that or look it up on GitHub. So Nerve System RPI PiCAN 2 is the one that I created that sets up most of what you need to do to have a nerve system that's ready to use that interface. And then you'll need a communication library, so that something that knows how to talk to a CAN bus. And you'll want, most likely, you don't want to sit in your vehicle every time you want to work on it. You don't want to sit there like directly connected to the thing. So I have mine set up to connect to the Wi-Fi at home and a few other places. So when it's parked, if the Wi-Fi connection is there, it will connect. And I've also set it up so that I can do remote pushes and a remote console. There is a warning. This is your vehicle. This is tapped directly into your vehicle's wiring. When you set up Wi-Fi and these remote connections, you want to be very, very, very careful that you make it secure. So I'm not going to go over that in this talk, but know that you want to make sure that somebody's not going to be able to connect to this thing and make it do stuff that you're not expecting. So very bad things can happen. And there was an article that you may have heard of a few years ago, Jeep Cherokee. There was some guys who were able to get in through the phone connection, cell phone connection, and did a proof of concept, like completely disabling this vehicle on the highway remotely. So you don't want that to happen to your vehicle. If you accidentally do it yourself, do it on private land. So don't hurt anybody. So is anybody familiar with device tree overlays? So there's a few people. It's a way of recognizing undiscoverable hardware that Raspbian uses, which is the OS that most people run on their Raspberry Pi. So when you build a nerves image for Raspberry Pi, you're actually building a Raspbian firmware underneath. And you need to tell that you have this new SPI interface connected. So the way to do that is to load a device tree binary. And I'm going to go over that pretty quickly. This is done in the PiCAN, or the RPI3 PiCAN firmware that system I created. Is already done for you, but I'm going to go through it because this is useful not just for the CAN project, but if you're doing anything with nerves and you need to load a custom piece of hardware, this is most likely the way that you're going to have to do it. And this wasn't totally obvious, and thankfully Justin sat down with me for like an hour in Slack one day and walked me through the whole process. I've since updated the nerves documentation to walk through this as well. So in order to change the firmware, you have to create this in your config file for your nerves project. You specify a custom firmware or FWUP config file. And this is a file that you grab from the system that you want to use. So if you're using BeagleBone Black, you'll go to Nerve System BB, I think it's called. If you're using RPI3, Nerve System RPI3. In the repository, you will find fwup.conf. And copy that into your project, and then you configure this to point at the location where you've put that file. Once you've done that, now you can actually go in and you can make some changes to the config. So the first thing that you have to do in this case is you have to tell Nerves to include your device tree overlay when the firmware is being created. In order to trim down the size of the images, most of the stuff is not included by default, even though it is on Raspbian itself. So you have to, you can go in, like what I did is I went to the Raspbian repository and I looked through the overlays that are there, and I found that one existed for the device I needed. So inside, and that was this one, MCP2515-CAN0. So here I'm creating a new file resource inside FWUp to tell Nerves that I'm going to be referencing this new file right here. And whenever I reference it, it's going to be pointing at, inside the Nerve system, there's the RPI firmware directory that has all of the Raspbian DTBO files. And I point to the one that I need. So if you're using any other kind of sensor, you will do the same thing. It just will be, instead of MCP2515, it will be the one that matches your specific hardware. And then now it knows how to reference that file, but it's not going to do anything with it. So you have to, inside, there's 3 sections. I didn't want to fill up the slide with like 6-point font, so I'm only showing 2 here, but this is the parts that dictate what files are moved around when you build an image, a firmware image. So it copies, on task complete, it will copy files over to the A partition of the device. So Nerves has this like A-B partitioning, so you can boot and not lock yourself out if something goes wrong. It'll always fall back to B, and if you boot on B and it screws up, it'll fall back to A, etc. So you add, you'll see in there where there's a bunch of other on resources, and you just add this additional line that references the file that you set up in the previous slide. And then you tell it where you want it to go. One second. Okay, I want to make sure I turn the mic off before doing that. There's also upgrade A and upgrade B, which move files around, that burn files to the firmware. You want to do this to both upgrade A and upgrade B. And something to note that stung me, because I was just copy and pasting and I wasn't totally paying attention. At the bottom there it says boot A part offset. If you put that in the upgrade B and it still says boot A part offset, it's not going to end up on B, and you're going to waste a lot of time trying to figure out why the file's not loading. So it has to say boot A part B, or boot A part offset for the upgrade A, and boot B part offset for the upgrade B section. And in order to load the device, Raspberry Pi, or Raspbian has this config.txt, which you can pass additional parameters and to load other modules in the kernel. Now that we have the DTBO, which is that device tree overlay file, on the system, we want to tell the kernel to use it when it boots up. In order to do that, we have to change this config.txt file. And the same way you do for fwup.conf, you go to the repo of the system you're using, you'll find if it uses this way. So this may be just Raspberry Pi specific. But you'll grab that and copy it into your repo again. Add a new file resource. Actually, this one will already be there in Raspberry Pi, or sorry, in the Nerve System RPI fwup file. There'll already be a line for this. You just have to change it to point to your config.txt instead of the one that will be defaulted there. And then inside your config.txt that you've copied, there'll be some other stuff in there. You're going to add the overlay line for your specific device. And most of the the manufacturers or wherever you buy these things from, they'll tell you what you got to put in there. You may have to tweak it a little bit, but you won't be totally in the dark. Usually this will be given to you. So in this case, I just add this device tree overlay with a couple, a frequency of the oscillator and an interrupt number. And then when I reboot my Pi and I reconnect to the console, oh, side note here, which I did not, this is my first Nerves project, and actually one of the reasons I decided to start this project is because I wanted to play around with Nerves a lot more than I have. I've just been doing blinky light stuff and nothing real. So I didn't know a lot of this stuff, but Nerves runtime shell was like super useful. I spent days troubleshooting stuff where I was actually running like system commands from Elixir before I think I just saw this like scroll past in somebody's in some random comment in the Nerves Slack channel, and this was life-changing for me. Nerves runtime shell. It basically gives you a pretty similar to a bash shell. It's not fully functional, but it's enough that you can poke around and investigate the file system and run some diagnostic stuff. So anyway, once you restart, you can check the log from the boot and you may see your device, like some message saying that the driver was loaded successfully. So now we can assume at this point that things are pretty much ready to go. You have to start the interface, and the easiest way to do this right now is just running system command on IP, and you just do link set can 0. This starts it up, and it sets the bit rate. So right here I have 125,000. That's specific to my vehicle. It's not going to be the same necessarily for your vehicle. It'll probably be 125,000, 250,000, or 500,000. But this is one of the first spots where it kind of varies depending on vehicle. And sometimes this is not just across manufacturers, but across models too. So different models of Jeep may have a different bit rate. And that should start the interface up. And you can check by going back into Nerves runtime shell. This is probably the easiest way to check. And if you just cat procnet dev, you'll see can 0. If you have not done anything up to this point, it'll say 0, 0 for the receive. There's actually a lot more of this. I just trimmed it down just so you get the point. But it's a big table that has some send and receive information. If it's hooked up to your vehicle and you do something like unlock the doors or open a door and close it, or so you just do anything, and then you cat procnet dev again, you should see packets start coming through. You should see that number change to anything aside from 0. So if you've done that, then that's the hardest part. Or that was, at least when I got to this point, I was like huge sense of relief, because it was such a pain for me at least to get to that point. So now we just need a way to talk to that thing. So we have our device, it's definitely sending data. Now we need to get to interact with it in Elixir. So there's two libraries currently. The first one that I tried out is called ngCAN. This uses socket can, and let me back up a bit. Socket can is, it's really cool. It takes a CAN device and turns it into a TCP socket connection. So you can talk to the CAN device as if it were a TCP connection. It's super useful. The downside is that it's Linux only. So I develop on a Mac. It was a pain in the butt to use that because I had to always have a second computer or a virtual machine up to play around with this. Because I was testing stuff locally before I would push it to Nerves. And ngCAN is relatively simple. I mean, the CAN interface is pretty simple, but this is just read and write. It's pretty bare bones. And this is how you use it. So I've highlighted here, I have in bold, you do a start link, you get the socket connection, and then you can open it up. And then I just stuff it back in the state of this gen server that I wrapped around it to manage it. So at that point, I'm connected to the actual CAN device. And then to read from it, this is where it also kind of, it didn't really work for me for what I wanted to use. So you can send the socket to await read inside ngCAN, and then you have to explicitly read the state over and over, which was not very useful for me. I wanted something that was a little bit more felt like events, and I didn't want to dive too far down into this path and find myself wasting a bunch of time writing an event system. It just felt a little too cumbersome for me personally. Oh yeah, so sorry, one more thing. When you call await read, it actually just sends a CAN frames message with one line, which not super useful, because these messages, there's thousands and thousands and thousands of messages. It's nonstop. It's a fire hose. So the same, it's a little bit more low level. To write messages, you come up with your ID, you have to build your own frame, and then you can write it to the port. And so realizing I wanted something that was maybe a little bit easier to use, or at least easier for me to use and understand. So I wrote this library called CANd. And what it does is it manages a socket CANd socket. So this is slightly different than socket CAN, which just makes the CAN device look like a TCP connection. This is actually a daemon that will run, listen on a port which you can then connect to, and with a regular TCP connection, and you can talk to it. And it has its own sort of its own protocol that it uses. So CANd library wraps that protocol. And the other benefit of this is that you don't actually have to be on the device that has the socket, or sorry, that has the CAN device. So you can just start socket CANd up on that device, which will expose the CAN connection to the network, and then you can be on another computer and you can connect to that thing and play around with it. Again, it was super useful because I'm on a Mac. Socket CANd, well, yeah, so now that we have socket CANd up, sending all these messages, CANd will listen to those messages, and it provides a way to basically just stream those messages, and you grab the ones that you care about and react to. And it provides some helpers so that you don't have to do something like this to send a socket, or sorry, a message. So it has a few a little bit more friendly ways to send a message. So with CANd to connect to the bus, it's pretty straightforward. You give it a, oh, I missed on here, so I actually started up a PID for this. Sorry, so there's one more start link line that's not on this slide, but that will return a socket connection to your CAN device. With socket CANd, you then can connect to the socket on that port, and this IP can be localhost or it can be anything else on the network. And then once you have that connection, you can't actually do anything until you tell it what CAN device you want to use, because socket CANd can be an interface to more than one CAN device. So here I say connect, and then we open CAN 0, which I know is the one that we want. Internally, what it does on that connection, it just uses GenTCP under the hood, which is nice. There's no dependencies for this library, which I felt, for me, I felt was a little bit important. And what it does is it just opens up a TCP connection and then stuffs it in the state of this socket wrapper. To listen to messages, there's a behavior that I have that's called listener. And you just have to define, it makes you define this listen function that will take a message. So there's a few different forms that will come. One that's just an OK. There's an error, and then there's just the message. And because these are just binary strings that always start with the ID of the message coming through, you can actually, like if you, let's say 2EB is the message for like the Windows rolling, like somebody's pushing the window up button, then you can just capture just that one message. You don't have to worry about the fire hose of all the other ones that are coming. And then if you wanted to catch them all, obviously you just take it and do whatever you want with it. So to set the listener, once you're connected, you define your own listener. There's a default one that will it's just standard out. It just takes all the messages and spits them right back out to the console. So most people, I think everybody, would actually want to do something custom, because that's the whole point of this thing. So you define your own listener, and you can either call set listener on the protocol and send it in, or you can pass it in as an option when you initially connect. And internally, what it does let me back up. There's two modes of interest on socket CANd. One is called BCM mode, which is you have to explicitly read the data if you want to receive anything. So you can send a message, but then you have to do your own receives. If you set it to raw mode, which is the more useful one, it'll just, anytime there's a message on the bus, it'll forward it to you, and it'll send it as a TCP message. Oh, geez, clicking, yowzer. So it'll send it as a TCP message, which you can then handle. And what it does internally on the socket module is it grabs the data and it just does some parsing. So it takes it, turns it to a string, chops it up a little bit to figure out what kind of message it is, if it's a frame message or an error message or just a state message like an OK. And then it passes it on to the listener that you've passed in. And if you don't pass in a listener, it uses that default listener that I'd mentioned, the standard out. And if everything's successful and you've connected and you hit your unlock button or you open a door or something, you'll look at your console and you'll just see tons of messages flying by. So this is what the CAN bus looks like when you're successfully listening to it. This was another moment where I was like overwhelmed with joy. It was like the first end-to-end moment. And this is just the ID, a timestamp, and then the data. They're pretty simple packets. And then writing into the system, there's a few different ways to do it. You can, that top one, you send with the ID, and this is hex, that's why it's a string. You can't just send like integer 295 because it might be 2EF or something like that. The 8 is the length of the data. So we're sending 8 characters, so we put 8 as that third parameter. Alternatively, I could just send an integer if I just want to send like something to a gauge cluster or something, then maybe I just need to send an integer, and I can do that, which internally is converted to hex and shoved into the network. And same thing with string. If you want to send, you want to send string data because, like in my case, there's some parts of the console that I can send text to. And when it's successful, look at that. It sends it. This is like part 3 of my, like the third exciting moment of like, I did something. So that's basically the end-to-end. From there, a lot of the work is in reverse engineering. So most of the tediousness is figuring out what those messages mean. It's not public knowledge, and it's different per vehicle. And like I said, it's not just different, like Ford different from Chrysler. It's like every single Ford model is different than every other Ford model. So this is just a list of useful tools that you're going to want to look at for that reverse engineering part. So CANutils is Linux utilities that are useful for like reading and writing to the CAN bus. There's a CAN dump, which you can run CAN dump on your device on CAN 0, and it will just dump. It basically just looks like this live stream of data. There's CAN sniff, which will do that, but it'll figure a lot of these are repeat messages, and it'll filter out the repeats, so you'll only see the ones that are changing. And that's probably the most useful of the utilities in CANutils, because then you can sit there and give it a second or two to kind of normalize and filter all the noise out, and then you can like hit that button that you are trying to get access to on your steering wheel, and you'll see it change. You'll go, okay, oh, cool, I know that like 6F0 is that button now. So figuring out, in this case, like what I need to write in order to override that thing, you have to sniff and decode to figure out. So in this case, I was basically, you have to encode the message. So this thing, one of the uses of this little section of the screen down there is to show you what the state of the stereo is, whether it's on like a CD or a radio station or something like that. So I noticed when you turn the car off, it actually updates that thing. So then I knew to start listening for that message. And I knew that if I had a USB drive in my stereo, it would send the word streaming. So I'm like, okay, cool. Then I can just look for any message that is the word streaming encoded. So you'll find yourself wasting most of your time doing that kind of stuff. It will take forever. It takes forever. There's also a program called Kayak that is platform independent that can be used to connect to the socket CANd connection. So you can actually use this to connect to the connection on your Nerves device, or on, maybe you're using this not in Nerves. You can connect to that and have like a GUI interface that is sometimes a little bit easier to use. It provides a way of capturing logs, which is useful for playing back logs, which is useful for figuring out what things do, because you're going to want to play, you record a log, lock the door, stop the recording, and then you play the log back until it locks the door. You cut it in half, you play half the log back. If it doesn't lock the door, then you play the second half back, etc. Like, it's a lot of that kind of stuff. There's an awesome book called Car Hacker's Handbook. If you're interested in this at all, I highly recommend getting that book. It goes over the CAN bus. It also goes over a whole bunch of other attack vectors for getting access to interesting electronic bits of cars. And that library CANd it's up on GitHub. I just pushed it last night. The documentation's a little light, so don't judge me if you look at it today. I'm going to spend tonight at the hack session here probably updating the documentation and fleshing that out a little bit more. And yeah, that's all I have. So thank you. Any questions? Questions? No questions? Nobody's got a question?
How do you power the Raspberry Pi? Through 12 volts and then through the CAN 2?
Yeah, so what I did is I spent a little extra money on that interface that had SMP, is that what it's called, SMP power? Basically, like, it could take 12 volts in, which then feeds back the 5 volts to the Raspberry Pi to power it.
What's the dumbest mistake you made in this project?
Oh, that's a good one. Oops, sorry, I just blew up the speakers. As I stated in the disclaimer, you can really screw things up. So the first time I hooked this up, and I fat-fingered the bit rate and turned on the Jeep. Everything worked fine. It was great. I went to send a message, and all my dash lights went on. And in this little area right here, it just said no bus. And nothing worked. And I was like terrified that I just killed, this Jeep was not cheap.
You bricked
And
your
I was
Jeep.
like, crap, my stupid antics, I just killed this whole thing. My wife's gonna be so pissed. That was the dumbest thing I've done. Thankfully, fixing it is just a matter of like unhooking everything. I think I had to disconnect the battery of the Jeep and hook it up. I might have just had to turn the key off and turn it back on. But
Yeah, you had to turn it off and back on again.
exactly, yeah.
I got it.
That was it. Like in hindsight, it wasn't that big of a mistake, but at the time, it was absolutely terrifying. Because this thing's only a year and a half old or something. I thought I just killed it.
All right. One moment.
I think one of the challenges we were having when we were running projects in automotive was the startup time of the beam, where you turn on the motor and it would take 2-3 seconds before the beam was powered up and running and could receive messages from the CAN bus. Has this affected you in any way?
It has not. So one of the benefits of the way that I routed the power out of the main harness is that the Raspberry Pi is always on as long as the battery is connected. So when I turn the Jeep off, the Raspberry Pi is still actually running. And it draws so little power that it doesn't really drain the system at all. So as soon as, if I just open the door, the thing will wake up and start receiving messages. I mean, it doesn't even have to wake up, it just starts getting the messages. So it doesn't, that was one of the other reasons to choose doing that as opposed to plugging it in USB, because a lot of the USB connections on the dash that were near where I wanted this thing to be are only powered on when the key is powered on.
Have you investigated any potential other methods of communicating with the CAN bus, like via Bluetooth or something, like existing communication ports?
There's no way to do it without having something connected to the wires.
Got it.
Yeah.
At least if you want to get everything.
A period, yeah. Because it's a signaling on those two wires. So you need something connected to those two wires. Excuse me. But there are easier ways to connect. There's two connections in that OBD2 port that's by the steering wheel. There's two pins that are supposed to be connected to the CAN bus. I've never connected them, but I think that might be the easiest way to get started in this.
Two-parter on this one. So what is your favorite, the flip of the bad thing, what is your favorite practical use you've come up with for this so far? And the second is, are you fighting against the system as it is? Like when you print "Don't Panic" on your instrument cluster and then plug a USB stick back in, does all of your progress get overridden? Like how do you intercept and change behaviors and make it stick?
Yep, so most of the, I'll answer the second one first. So there is some stuff, like right here it says "Don't panic." If I'm driving the Jeep, there's some things that will trigger an event to overwrite. Like if I'm somehow magically getting good mileage, it'll write the word "eco" there, and it just blasts away. If I had anything else there, like one of the ideas was to have real-time GPS coordinates printed right there. Oh, I'm sorry. And I'd basically have to be monitoring for that eco message. And if I ever detected it, I'd have to have a listener overwrite it again with my data. And for practical uses, to date so far, sorry, I'm still in the middle of the reverse engineering state. But what I want to do is, our Jeep is the year before reverse cameras were made mandatory. So I think one of the projects we would like to do is have a touchscreen display on this that we can have additional custom gauges for air pressure and that kind of stuff in the tires, which is also messages that are on the bus in my system. But also to have it, if it detects that I put it in reverse, I'd like it to connect to, like another Raspberry Pi in the back with a camera that turns on so that I can see that I'm not going to run over my kids or a cactus or something like that.
DIY backup camera, huh?
Yeah. It's probably much cheaper and definitely quicker to go buy one, but
Where's the fun in that?
Yeah, exactly.
This was a really cool talk. Definitely one of the coolest talks I've seen in the Elixir conference thus far. But then again, that's just about every single Nerves talk. Anyway, give it up.
Ends up being a process group that I accidentally wrote when was trying to write presence. So what I'm really good at is I can solve a problem on I want to show a list of users on a web page, and that's what Phoenix Presence started as. And I solved that problem from the top down, and then Jose comes in bottom up and tells me what's wrong with everything. But no, it's he comes in and he's like, this tracker thing that ultimately really Phoenix Presence is using this thing called Phoenix Tracker. And I wrote that to solve that presence issue. And then Jose is really good where he comes in and he's like, Chris, Phoenix Tracker is actually 3 separate things that you wrote and made it one thing. So the tracker is handling node discovery and detecting when nodes come and go in the cluster. It's handling replicating TRDT data. And Phoenix PubSub even, Jose was like, Phoenix PubSub is 2 separate things. There's an RPC mechanism there. So it's great. So Jose has come in and said, we need to break this great work that's happening in Phoenix PubSub and the tracker into smaller pieces, and then have that be a foundation for a distributed toolkit. That way people can message in another node on the cluster. It's still going to have PubSub, right? It's still going to have the process group that supports Phoenix Presence, but it's going to be smaller pieces that we can then use to tackle some of these problems. And I said, just like Elixir, like it turns out the Elixir registry actually it's only a local registry only, but Elixir itself is starting to think about some of these problems as well. Like how do we discover processes? Right now it's local only, and long term I'd like to see a global registry. The Erlang OTP folks are supposed to be working on a better, like Erlang Global exists today, but has some scalability issues depending on the scale that you're operating at. So we're kind of waiting on see if they solve all of our problems for us. But I think whether you're using Phoenix or Elixir, like the goals are like we have like Elixir task module. So like Jose came in and said like, wow, Erlang has these primitives which are amazing. We can spawn up little bits of concurrency, but like if you just wanted to use all your CPU cores, that was actually kind of hard to do in Erlang as far as like just being able to have cheap concurrency at your fingertips. So Jose has added tasks to the language. Like we want to, in my mind, continue to take like we have these amazing primitives, these amazing features of the language, and how can we create libraries to help you really leverage those. If we do that, I think we really, truly will eat the world. So that's all I have. Again, check out Dockyard, give them a big thank you. There's several of us here at the conference, so if you have any questions about Dockyard, reach out to me, but that's all I got. And I don't know if we have time for questions, but where's Jim at? Jim in here? If you have questions, happy to take them. All right. Oh, we got Dave.
Actually, no, I think what you're saying is absolutely right and really phenomenal. I just have one request, really.
Sure.
And that is, all of these new things that you're thinking of doing, and some of the things you've already done, like Elsa, can you keep them separate rather than bundling them all into one big thing? The same goes on the Elixir side as well.
Yeah.
Because I think one of the mistakes that we see now is beginning these coupling happening between all the different libraries, which means you can't pick and choose, and you can't use them in context they weren't designed for.
Gotcha. Yeah, so I would say yes. So like it's too early to talk about, but we've started work on breaking down the Phoenix Pub Sub into a new library. And it exists under the Phoenix Framework GitHub organization, only because we were going to make it separate, but like PubSub is my baby, so like, I'm not ready to let it go yet. But it will be, the namespace of the library won't have Phoenix in it, so it will be totally outside that idea. But you're right. So I have, like the longer story is like I have thought about this where if we make this distributed tooling library that does PubSub and RPC, and then how do we end up rewriting presence on top of it? Like I do see it start getting pretty large. Like if we're starting to have its own CRDT implementations, like it would be nice to like at some point where we can't just throw everything in this library, right? Because it will eventually become a database. Like accidentally, like they'll use this new library and it turns out to be. So, but yeah, you're right. So I think I will definitely keep that in mind. That's a good point.
Well, I agree with Dave. What you guys are doing is great because you're bringing this knowledge that we have about stateless, and now we are going into state. But let's not forget that the Erlang people have developed some great tools. You were talking about ETS, and we also have, Erlang also has amnesia. They have solved a lot of the problems that you had thought, and you can have amnesia, RAM copies, and fragmentation, and a lot of the problems that at the beginning we try to use ants or debts, or then we go to Postgres, there's amnesia in the middle that solves some of the problems.
Yeah, absolutely. Yeah. So amnesia for me is there's definitely some. I feel like people using amnesia really well. Like don't get me wrong, I think there's some amazing engineering there, but the people that use it well, I feel like you have to be like an amnesia expert. Because for me, especially, like if I deploy a system for a client and they end up with a fragmented or corrupt amnesia table, like that's your database is ultimately like sacred, right? So like if your data is sacred and you end up with a net split, you have diverging tables. It's like I'm personally not comfortable coming in and trying to solve that. So I wouldn't say never use Amnesia, but I've never been comfortable enough to not use a traditional data store if I need that kind of consistency. But I have heard people using it, you know, at domestic success, so your mileage may vary. All right, just find me